Hey guys, how you doing? This is Coach Scott, Purple Wave Chemistry. Just want to give you the first day lectures in case you have to miss it for some reason. So we're going to start talking chemistry this year with, well, where does stuff come from, right? And let's look at what we call the Big Bang. So what we can see in the universe, if you look up at night, look at the stars, you see everything we've done. It, it's all made of amazing stuff. And this stuff, which is really the study of chemistry, we call this stuff matter. Now, we've always been curious about what matter is. Where did matter come from? Uh, what is it made out of? And why does it behave the way it does? So, chemistry, let's get a definition of what chemistry is. I'll tell you, chemistry is the study of stuff, the stuff that we call matter. And what's the properties of this matter, and how does matter interact and change? So, in chemistry, we can predict the behavior of stuff, and we can predict what should come out of a chemical reaction. So, what is matter? Here's our definition. Matter is anything that has mass and occupies space or has volume. Now, the smallest particle of matter retains its properties. What is the smallest particle? Is something we call an atom. So, we know of 118 different types of chemical elements that are made up of the same element. 90 of these are found naturally, and the other 28, 38. The other 38 are man-made. So where do the elements that make up the universe come from? Well, if you said Genesis, you're correct, because that's the beginning. And the prevailing model from what we can see of what we can measure, that where the universe came from and what the stuff is that make up the universe, is something called the Big Bang. And it happened about 14 billion years ago. So we believe, the evidence suggests that the universe began at a single point. Now, this spot where stuff was small. It was 1,000 times smaller than the head of a pin. It's so hot and more dense than any object that we know of today. Now, this heat still retains from something we call cosmic background radiation, which is evidence of the Big Bang. So the universe began expanding suddenly and rapidly from this single point. So every piece of matter, all the stuff that makes the universe, including me and you, came from this small, dense spot. So 14 billion years ago, in the flash, it was all darkness, right? And then there was light. In a flash, the Big Bang, high energy photons, which are light particles, collided with each other and they formed oppositely charged particles. Now, usually, when oppositely charged matter and antimatter, they should have annihilated each other instantly, and a lot of them did, and they'll convert back into high energy photons. But for some reasons, which nobody can explain yet, about one particle of matter survived for about 1 billion particles of matter and antimatter that were annihilated. Now, these surviving particles make up the stuff of the universe. So 3 types of these particles would form atoms as the universe began to cool down. So as the universe expanded, both the plasma and radiation filling it grew cooler. Now, when it cooled and stable atoms could form, they eventually could no longer absorb the thermal radiation, and the universe became transparent instead of being an opaque fog. The photons from that time have been propagating ever since, growing fainter and less energetic. Now, if you're watching this, there's a video on Blackbaud about the Big Bang. I encourage you to watch it. So, next we're going to talk about the elements that were formed. So, let's talk about hydrogen and helium. So, it's important to understand about atoms when we start studying about elements. Now, what are atoms? And we've been discussing this for thousands of years. As early as 450 BC, ancient Greek philosophers would debate this. Now, there was this guy called Democritus. He asserted that all matter was made up of small particles, which we couldn't really see, too small. He called these particles atomos. Now, this was in disagreement with the famous Aristotle. He said that all that matter was composed of earth, air, water, and fire. Okay? So Aristotle's description, that was the commonly accepted belief for thousands of years. Now, eventually Democritus he was right. But he wasn't proven right until about 2,000 years later when John Dalton proposed his atomic theory in 1808. Now, John Dalton was a British physicist and chemist, and he studied the way gases combined to form compounds, and he noticed certain patterns. From these patterns, this allowed him to develop his own atomic theory. So, out of this atomic theory, he proved the law of definite proportions and also Dalton's law, which we'll cover later when we talk about gases. This describes the mixtures of gases and the pressures. Okay? Now, these two laws, again, we'll study these later. So, all matter, here's his 5 points. He said that all matter is made up of tiny, indivisible particles called atoms. Right? Atoms. And remember, he did this around 1800. All atoms of a specific element are identical in mass, size, and other properties. Now, atoms of different elements exhibit different properties and vary in mass and size. Let's see if this makes sense. Atoms cannot be subdivided, created, or destroyed. Atoms of different elements combine in simple whole number ratios to form chemical compounds. In chemical reactions, atoms are combined, separated, or rearranged. Now, this is in 1800, remember. They didn't have all the tools that we have now. Now, most of the theory, Dalton's theory, still holds true. But with more advanced technology, we've got a little different picture. We've changed his model. So two of the most important differences are, well, atoms can be divided, and they're made up of smaller particles. We call these protons, neutrons, and electrons. All atoms of the same element are not identical. All right? These different atoms, well, they'll have different neutrons, and we call those isotopes. And we'll talk about these later. So, atoms are made up of 3 subatomic particles. You may remember this from 8th grade. Protons, neutrons, and electrons. Protons have a +1 charge, and they have a mass of around 1,800 AMUs, around 2,000 atomic mass units. Neutrons have no charge. They're neutral. And they have a mass around, again, about the same as a proton, around 1,800 atomic mass units. Electrons have an opposite charge that is equal to a proton, we call it -1, and it has a mass much smaller than a proton or a neutron, around 1 AMU. Okay? So, protons and neutrons, they're about 2,000 times heavier than an electron. Okay? And again, protons and electrons have equal and opposite electrical charge. Neutrons have no charge. Now, protons and neutrons, you can think of them as being in the center of the atom, all right? And we say that forms the nucleus. we call these things that are found in the nucleus nucleons. So the electron moves around so rapidly that we can never know exactly where the electron is. We call this an electron cloud. So again, the protons and neutrons are 2,000 times heavier than an electron, so that means most of the mass of an atom is in its nucleus. Protons always have a positive electric charge, which means that they're trying to push each other apart, just like two positive poles of a magnet. Electrons, they have a negative charge, so they're trying to push each other apart. Whereas the opposite electrical charges will attract. The protons and electrons should attract, and they do. Now let's think that most of an atom, all right, is empty space. Think about it. So think about an atom as the size of the Liberty Ball. If you put the nucleus, it'd be about the size of a pea, in the center of the 50-yard line, then an electron could be anywhere inside of that stadium from the very top to any of the seats in the first line. And, it's so far away. So any electrons in this atom would be so small to see. You couldn't even see them. And they'd be constantly moving throughout that stadium. So think about it. Most of an atom is empty space. And we just learned this about 100 years ago. Now what's filling this empty space? Well, nothing. It's not air. But what's in the most of an atom? Well, nothing. What are we made of? Atoms. So what are we? Mostly empty space. So if I was to kick a soccer ball with my foot, I'm kicking mostly empty space with mostly empty space. So what makes the soccer ball go? What makes us feel? Well, it's the repulsion of these negative electrons within the atoms, and that's what makes it feel solid. So when you kick a ball, the electrons in the ball interact with the electrons in your shoe, and this provides the kick. So most of what we're going to study this year in chemistry are how do electrons act. So anyway, guys, that's the beginning of our chemistry period and what we're studying. It's going to be fun. It's going to be a blast. So this is Coach Scott saying, holla baloo, knick, knick.